Hello there again. This is Algebra 1, Chapter 3, Section 5. Arithmetic sequences as linear functions. And yes, that is pronounced arithmetic. It's interesting, if you were just talking about that one word, you could say arithmetic. But when you add it to the word sequences, you can't say arithmetic sequences. It's arithmetic sequences. Just a tidbit of information there for you. But anywho, an arithmetic, or not necessarily, let's backtrack a little bit. A sequence is basically a set of numbers. And each number that's in the sequence is called a term of the sequence. So what we'll want to do is look for a pattern in the information that's given in this first table. And we'll talk a little bit about what makes it arithmetic and what makes it not arithmetic. All right, so for example, as I compare these two numbers here, I'm not really concerned about the distance up on top, more as the times here. 132 to 304 is adding a whole minute to the 132 and 32 seconds. If I add 132 and 132, I'll get 264, and 64 is an extra minute, so that would be 3 and 4 seconds. And then if I go from here, I don't know if you're noticing this pattern yet, but if I add a minute and 32 seconds to 3 minutes and 4 seconds, I'm going to get 4 minutes and 36 seconds. So again, you're adding a minute and 32 seconds. As I compare the next two numbers, if I add a minute and 32 seconds to 4 minutes and 36 seconds, I'm going to get 5 minutes. And let's see, 36 and 32 is going to be 68. So again, the 68 is going to bump it up an extra minute. So now we're at 6 minutes and 8 seconds. So again, we're adding a minute and 32 seconds. And then the last one, if I add another minute and 32 seconds, I'm going to get to 7 minutes and 40 seconds. So each time, I am adding the same amount of time, which is a minute and 32 seconds. So this is an example of a sequence that is arithmetic, because as we can see down here in the description, an arithmetic sequence is when the difference between successive terms is constant. And in this case, each term was, the difference was a minute and 32 seconds. So therefore, this particular example is an arithmetic sequence. And we call that difference that's the same, the minute and 32 seconds, is what we call the common difference, and we denote it by the letter D. Okay, so we want to go and show you some examples of how this works up here. I have a couple of sequences here. And again, we can find the common difference by just subtracting the previous term, subtracting the previous term from the next term. In other words, I'm going to start here with 5 and subtract 3 and get 2. In the case of the 7 and the 5, I'm going to go 7 minus 5, and I'm going to get 2. Then I'm going to go 9 minus 7, and that's going to be 2. And 11 minus 9 is also 2. Which is why we call it the common difference. Because difference means subtraction. All right, so then for these two, I'm going to go 29 minus 33, which is going to be 29, 31, 33, so that's going to be 4. Then I'm going to go 25 minus 29, and by that's negative 4 there. So if I go 29 minus 33, 25 minus 29 is also negative 4. And then the next two numbers are going to be 21 minus 25, also negative 4. And then of course 17 minus 21, also negative 4. Okay, so just so that you're aware of how to, so for this first example, the common difference D would be 2. And since these were all negative 4, the common difference for this guy would be negative 4. So the common difference can be negative or it can be positive. Alrighty, so then we have our first example that says, determine whether each sequence is an arithmetic sequence and explain. Now remember that the only way for it to be an arithmetic sequence is for the common difference to be the same throughout all the pairs of numbers. That's what we're going to do right now. We're going to calculate them. So I'm going to start here and go negative 2 minus negative 4. Now be careful with the minus negatives. That's actually negative 2 plus 4. and 4 minus 2 is 2. In the second numbers, I'm going to say 0 minus negative 2, and again that becomes a plus 2, and once again I have 2. And in my last set of numbers, I'm going to go 2 minus 0, which is just 2, and since they all have the same common difference, which is 2, then this is a yes, it is arithmetic. By the way, all sequences have these 3 dots at the end, which indicates that the pattern is going to continue, and that is actually called an ellipse, an ellipsis. So that might be something that, I don't know, might come up in a quiz as a bonus question maybe. It's an ellipsis. Ellipsis. I'm not sure if I'm saying that right, but that's what it's called. It's called an ellipsis, ellipses. But that's basically what these 3 dots mean, and it indicates that the pattern is going to continue even though we don't see those numbers. So just minor information there for you. So now we're going to go over here, all right, and we are going to do the same exact thing, and we're going to say 5/8 minus 1/2, and 5/8 minus 1/2 is 1/8. Okay, so the 1/2 would be the same thing as 4/8, and 5 minus 4 would be 1. So then we're going to come over here and say 3/4 minus 5/8, and again to get a common denominator, we have to times this by 2, so this is going to be 6/8, and 6 minus 5 is 1, so it'll be 1/8 again. So our last one is going to be 3/16 minus 3/4. And in this case, we have to take the 4 times 4. This is actually going to be 12. So this is going to be 3/16. And if I times top and bottom by 4, I'm going to get minus 12/16. And 3 minus 12 is going to give you negative 9/16. And that is not the same thing as 1/8. So this is a big fat no as far as being an arithmetic sequence. Sorry about that. Okay, so they didn't all have the same common difference, so it's not an arithmetic sequence. So you want to be careful that sometimes, even though the first 2 were correct, sometimes it takes the last term, and so you have to just make sure that you can stop checking once you find one that's not the same. But if the first 2 are the same, you can't assume that the second and third will be the same. So always want to make sure that you go through the whole thing, unless you find one that doesn't work, that is not the same common difference, and then you can stop. So now we're going to let you try this, do it yourself, and then we're going to go on to the next example. Example 2 here. And it says, find the next 3 terms of the arithmetic sequence. In order to find the next terms, we kind of have to know what the common difference is. That's the first thing I'm going to do, is go 9 minus 15, 3 minus 9, and negative 3 minus 3. So 9 minus 15 is going to be negative 6, 3 minus 9 is negative 6, and negative 3 minus 3 is negative 6. Since they're all negative 6, that means that my common difference is negative 6. So if I basically subtract negative 6 from each number, so 15 minus 6 is 9, 9 minus 6 is 3, 3 minus 6 is negative 3. Now I want to find the next 3 terms. So negative 3, I need negative 3 minus 6, which is negative 9. And then I need negative 9 minus 6, which is going to be negative 15. And then I need negative 15 minus 6, which will equal negative 21. And the next 3 terms in the sequence would be negative 9, negative 15, and negative 21. And that's pretty much how you do that. So now I want you to do this one. Now remember, this is actually 4. It wants the next 4 terms of the sequence, so just be careful with that. All right? And then we're going to pause for a moment here. We're almost done. But now we're going to talk about the formula for an arithmetic sequence. And so this is the formula. It's called the nth. It's a formula for the nth term of an arithmetic sequence. And all of these variables have a responsibility, so to speak. So I kind of wanted to just make sure that we could talk about what each letter represents. First of all, we talked about the whole like subscript in the last lesson, I believe, or 2 lessons ago. So a sub n, a sub 1, that's how you say it. But a sub n, what that represents is the value of the nth term. Okay, a sub 1 is the first term, n is the term number, and then d is the common difference. So out of all of this, the one that's probably the easiest to understand is the common difference. So we already know what that is. That's where the d goes. That's the common difference. The ones that get kind of confused are these 3 here. So I'm going to be really clear and kind of explain how this works to you. I kind of tried to, I made a sequence here. It's a pretty easy sequence, but the point of me doing this is just to give you an example of how this works. The first term is easy too. It's always the first term in the sequence, so that's why it's color coded there. So 2 in this scenario, 2 is the first term, so 2 is a sub 1. And then the one that gets kind of confusing is the term number and the value of the nth term. So the term number refers to, this is the first term, second term, third term. I should probably be doing that in the same color as the term. So the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, and so on. So the blue one is the 6th term, which means that n would equal 6 in this case. Okay? But a sub n is not 6. A sub n is asking me or telling me the value of the 6th term. So when I say nth here, and since n was 6, it's like saying, what is the value of the 6th term? Well, the value of the 6th term is actually 12. So that's 12. And I want to show you how this formula works, because according to the formula, we have a sub n, which is 12. We know that in this scenario, a sub n is 12. We know that the first term in this scenario is 2. We know that the n value in this scenario, the 6th term, that's the one that I'm highlighting here. This guy right here is the 6th term, so n is 6. We always subtract 1, and then we multiply it by the common difference. And the common difference is found by taking 4 minus 2, which is 2, and 6 minus 4, which is 2, 8 minus 6 is 2, 10 minus 8 is 2, 12 minus 10 is 2, and 14 minus 12 is 2. So the common difference is 2, so we put a 2 here. Now we're going to solve this guy, and we're going to see that it's actually a true statement. So we're going to get 2 plus 6 minus 1 is 5 times 2. That's 2 plus 5 times 2 is 10, and you get that 12 does in fact equal 12. So you can see how the different variables in the formula relate to the equation and how you can plug it all in and you'll get the true answer. So now we're going to try an example with that, and it says write an equation for the nth term of the arithmetic sequence. So one of the first things I need to figure out, I'm definitely going to have an a sub n, and then the first term in this sequence is negative 12, so we're going to put our negative 12 plus our n minus 1, and the last thing we need is to find the common difference to be able to plug into our formula. So we're going to do this, and we're going to go negative 8 minus negative 12, which is negative 8 plus 12, and 12 minus 8 is 4. And then we're going to do this, we're going to go negative 4 minus negative 8, which is negative 4 plus 8, and again 8 minus 4 is 4. And lastly, we're going to get 0 minus negative 4, which is 0 plus 4, which again is 4. So because they're all 4, the common difference is 4, and we're going to put that right there, and that is actually the formula for this example. Negative 12 plus n minus 1 times 4. If you want, you can actually now at this point keep simplifying it. So now I can say equals negative 12 plus, and I'm going to distribute 4 times n is 4n, and 4 times negative 1 is negative 4, and then I'll combine negative 12 and negative 4 and get negative 16 plus 4n. And that would be my arithmetic sequence equation. A sub n equals negative 16 plus 4n. All right, now, what do I do with that equation? So for part B, it says find the 9th term of the sequence. So because they're telling me that they want the 9th term, that means that my n value is going to be 9. So all I have to do to find the value of the 9th term, remember that the value of the 9th term is represented by A sub 9. Okay, remember A sub n, but n represents the term that you're looking for, and I'm looking for the 9th term. So A sub n, the value of the function will actually equal negative 16 plus 4 times n, and in this case, n is 9. So then, I can get my answer to be negative 16 plus 4 times 9 is 36, and 36 minus 16, so 20. So the value of the 9th term is going to be 20. And then we have our last question here where it says, which term of the sequence is 32? So they want to know which term. So when they say, again, question, which term, that means that we don't know the answer to that. So right now, we need to find n. We're not going to know what n is. But it wants to know which term of the sequence has 32 as value. So that means that A sub n equals 32. So using that information, we can plug it into our equation and solve for n. So I know that A sub n equals 32, when the equation says here, so I'm going to replace A sub n with 32. Plus 4n, and my job is to now solve for n. So I'm going to add 16, so that's going to give me 48 equals 4n. Then I'm going to divide by 4 on both sides, and it turns out that n actually equals 48 divided by 4, which I believe is 12. So it means that the 12th term of the sequence is 32. Alrighty, so now we're going to let you try one on your own, and then we're going to do our last example, which is a word problem. I know how much you guys love those. Okay, so it says here, Marisol is mailing invitations to her quinceañera. The arithmetic sequence 0.42, 0.84, 1.26, 1.68 represents the cost of postage. Write a function to represent this sequence. So the first thing we have to do is to find our common difference. So we're going to try those right there. We're going to say 0.84 minus 0.42. So 0.84 minus 0.42 is going to be 0.42. Then we're going to get these two, and 1.26 minus 0.84. So 1.26 minus 0.84 is 0.42. And then lastly, we're going to go 1.68 minus 1.26 and also get 0.42. So our common difference is 0.42. So to write the formula, we're going to get A sub n equals our first term, which is 0.42, plus n minus 1 times the common difference, which is 0.42. We can then simplify that. 0.42n minus 0.42. So what's going to happen there is that this positive 0.42 and negative 0.42 are going to cancel, and all I'm going to have is A sub n, equals 0.42n. And this will be my equation for my arithmetic sequence. Now to graph that, all we have to do is take all of these and make them some points. So, let's see here. I think I'm going to go by maybe 25 cents. So that's 25, 50, 75, $1, 125, 150, and then 175, and then $2. So, and then we're going to go, we're just going to go ahead and label these the first term, second term, third term, fourth terms. We're just going to go 1, this is 0.25 by the way, and then that's going to be $1, $1.50, and $2. Okay, so 1, 2, 3, 4. So we're going to say that when x is 1, you get 0.42, so less than 50 cents, so somewhere right there. At 2, you're going to get 84 cents, which is more than 75, so somewhere there. At 3, you're going to get $1.26, so this is $1.25, so right about there. And at 4, you get $1.68, which is above $1.50, so somewhere right around there. Alrighty? And that's basically your graph. And then it says to talk about the domain. So I want to do that real quick. The domain of this function. Domain is basically the input values, the x values. And so in this case, the x values represent the invitations. How many invitations? 1 invitation, 2 invitations, 3 invitations, and so on and so forth. So the domain in this case has to be integers. In other words, we don't want to have negative x values. Okay, no negative x values, because that would imply that she has negative invitations. It doesn't make any sense. We also can't have fractions or decimals. Because if we had allowed decimals and fractions, and that means that you could have 2.5 invitations. She's not going to send somebody half of an invitation or a portion of the invitation. She's either going to send the whole invitation or she's not going to send it at all. So in that case, it means that the domain has to be integers. So things like 1, 2, 3, 4, ... Okay? So the domain for this guy is basically only integers, but of course not including 0 or negative. So 1, 2, 3, 4, ... This is going to be my domain for this function. Alright, so now you're going to try this example on your own. And once you have done that, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.